thank you very much, Meuleman. Thanks for the very generous and nice introduction, and also for the invitation. And I would also like to thank all participants present here to join us for this discussion today. I think it's a discussion that at least I find important, and there's still so many things we need to discover. So I'm very happy to see a lot of people here that are willing to exchange thoughts. I'm trying to share my slides. In the meanwhile, okay, by now you should be able to see them. If not, let me know. Okay, so what is the topic of my presentation today? So it's about measurement invariance, and I want to address the question whether the way in which we use measurement invariance tests, whether it's really helping us forward when we want to do a comparative research. And so I have a subtitle between statistical dogmatism and anything goes. I hope this suggests to you that I'm going to try to take a bit of a nuanced position here and make a bit of an overview of things that are relevant in this technique, but also things that we could do better. And maybe as to start, a bit of background, why this topic. The background is that in the recent months and years, there was some discussion back and forth between several colleagues in comparative research. And the whole background is that these tests for measurement invariance or equivalence, they are becoming more and more often used. They are becoming more and more prerequisites to publish in the domain of comparative value research. And some researchers see this as a welcome evolution because it could increase methodological quality of the work that we're doing. But there's also some critical voices. And one very notable critical voice has been the one of Christian Welzel that has presented in the seminar series earlier. And then who has written with several colleagues a number of papers where they quite heavily criticize the practice of invariance testing. And here I took a quote from a paper in 2019 where they maybe use a bit of a hyperbole, but would say, okay, the specter is haunting academia and it's a specter of measurement equivalence. And the idea here is that we're always trying to test measurement equivalence. We're increasingly doing this, but it's not doing us a lot of benefit. It's in fact harming our research. And so it's precisely this statement that I want to discuss together with you. And so what I will present today is also written down in a paper. It was a commentary paper on a paper that was first published by Christian Welzel and his colleagues recently in Sociological Methods and Research, entitled Non-Invariance, an Overstated Problem with Misconceived Causes. And in a nutshell, the gist of this paper is that you can test for measurement invariance, but it does not do you any good because even if you violate the assumptions of measurement invariance, valid comparisons are still possible. And so it's investing a lot of time in something that is not useful and that might be misleading. And I like this paper because it's provocative and it makes us think about certain important issues. But I also took issue with certain statements that have been made. And so with a couple of colleagues, we wrote a commentary paper, why measurement invariance is important. And so what I will present today is also written down in this paper. And so it's not only my ideas, but it's a collaborative effort with a number of colleagues. I have to say that there was also a second commentary paper published with the lead author Ronald Fisher, who is, if I'm not mistaken, present here today as well among the participants, focusing on one particular aspect of the claims of Welzel and colleagues, and then specifically on nomological noise. And so what I wanted to do today is not really repeat this whole discussion, but more present a couple of things, what I have learned through this discussion, because I enjoyed this discussion a lot. I think it has invited us to rethink certain issues and to reformulate particular points and refine our statements. And so what I have in mind for today is really to discuss together with you about the question, if you look at what we do nowadays with invariance testing, is it really useful? How useful is it? And if we say that it's not useful, what should we do instead? Can we replace this practice by a different strategy of assessing measurement quality? And so I hope you don't expect a real technical explanation. What I have in mind is a really basic discussion, a more conceptual discussion. I would like to start with going back to the basics and asking myself, what is measurement? What are we trying to do when we measure something? And so it's a whole step, a big step from a theoretical construct to a measurable variable, but what can go wrong and what kind of theories on measurements are we using, often implicitly, right? And after going back to the basics, I want to apply this to the realm of comparative value research. And so if we take these basic positions into account, what does it imply for the comparability of measures across cultures and countries? And how should we deal with the gap between, on the one hand, the cultural level, and on the other hand, the individual level, because we want to make claims about cultures, but our measurements are done at the individual level. So what does this imply for our measurements? And then I hope to come to a conclusion. It will be a preliminary conclusion. And this conclusion will be my answer. Do we then really need a paradigm shift? Do we need to abandon the invariance testing? And do we need to replace it by something else? And then I hope that we can have a fruitful discussion afterwards, right? Okay, let me start with the basics. And yeah, it's really very basic. I hope I'm boring you. But so what is measurement really about? What are we trying to do when we try to measure something? Well, it's the point of departure is always a theoretical concept. We have particular concepts that figure in our theories, but then we want to investigate them empirically. So we need to have an empirical indicator of these concepts. And so measurement is the whole process of linking an abstract theoretical concept to an empirical indicator, right? And I think that measurement quality should be of a continuous concern. So when we link an abstract concept to an indicator, it's a very big step. A lot of things can go wrong. And so we need to be really careful and think about measurement quality. And how can you define measurement quality in a very generic way? You could say, well, what we want to have is if there is a change in the theoretical concept, it should be reflected by changes in the observed indicator as well. The observed indicator needs to respond to changes in the theoretical concept and only to changes in this theoretical concept. Now, how can we really assess this measurement quality, and how can we go about it, and what can go wrong in this whole procedure? Well, I think it's important to understand that measurement, it's a procedure in several steps that you can lay apart conceptually. Often they happen at the same time, but at least conceptually you can lay them apart. And here I think it's useful to make use of the total survey error framework, and this tells you what my background is. And so Meuleman already introduced that I'm coming from the comparative survey methodology, and in survey methodology, a very influential framework to think about all kinds of things that can go wrong in surveys is the total survey error framework. And the backbone of the story here is that we want to estimate a survey statistic. For example, we want to have an average in a certain population, or a difference between two populations. This is the survey statistic that we want to estimate. But when you estimate the survey statistic, all things can go wrong. Things can go wrong on the side of representation. It might be the case that the sample that we investigate does not represent the population that we want to talk about, but I'll leave this apart. But then we have the second leg of this total survey error framework, which is then the measurement part. And also in the measurement part, all things can go wrong. So we start from a theoretical construct or concept. I like to use it concept rather than construct, but here in the total survey error framework, it's called construct. And then this construct or concept is translated into a number of indicators. So it's made operational, you could say. And here, first thing can go wrong. If we select certain indicators, they do not necessarily reflect the underlying concept very well. So here we have the issue of theoretical validity that is at stake. Once we have a series of indicators, we still need to record scores on these indicators, right? Typically, the indicators could be a series of survey questions that we present to respondents. Respondents, they respond to it, but their responses do not necessarily reflect what we want to measure, what we had in mind with the indicator. So all kinds of measurement errors can creep in here as well. And it can be systematic errors, can be random errors, right? Once we have the responses, we edit it into, for example, a scale. And then based on this scale, we make statements about a survey statistic. And so here I would like to zoom in on this measurement part, and then specifically the step from construct to response. I won't talk too much about editing the data. I think it's of importance as well, but not so much for this discussion. So really, as a basic layout, you could say measurement is starting from a concept, translating it to indicators, and then we use the indicators to come to a measured variable, right? And here we want to make sure that this process is as smooth as possible, that we have as little errors creeping in as possible. But the big issue is that very often this is a kind of a black box. Of course, we start from a concept, theoretical concept, and then we end up with a score that we observe. But what goes on? How do we travel from this concept to the score? And how can we really know that things have gone, that things have not gone wrong, right? And so the whole issue of assessing measurement quality is trying to find out if the measured variable is adequately reflecting the theoretical concept. And there exist numerous approaches to assessing measurement quality. And I think they are all useful in their own right. But maybe summarizing, you could distinguish three bigger approaches. One approach is a more theoretical approach, where you say, okay, we don't necessarily look at empirical results, but we make a theoretical exercise. We think carefully about the dimensions a particular concept should have, the proper indicators, and then in this way we try to say something about how good measurement will be. This is more or less the logic of content validity, right? Now, other approaches are more empirically grounded. They take a look at the data and try to see if the measurement approaches are valid and sufficiently reliable. And so one other logic is external validation. So let's take the end product, let's take the measured variable, and then let's try to link it to other variables that we measure. And in this way, indirectly try to say something about the measurement quality. This is, for example, the logic of criterion validity or construct validity, where we say, okay, if we have a particular measure and if it correlates as expected with another measure, it's an argument to say that the measurement is of good quality, right? And this is exactly the point that Welzel and colleagues are making, that we should put more emphasis on this kind of external validation, that we should, for example, look at nomological networks. If we have a measure and if it correlates strongly as expected with other concepts, then it's an argument in favor of good measurement quality. Now, a third approach is then really trying to model statistically the measurement process. And here I put this in bold, not necessarily because I would say that this is the only way to go or the most important one, but this is the one that I'm talking about today, because when we talk about measurement invariance testing, this is the approach that we're taking here. So what do we do when we try to use the approach of statistically modeling the measurement process? We try to take a peek into the black box. So we do not really focus on the end product only, but we try to see how certain indicators work together and how they are transformed into a measured variable. And we try to test by means of statistical analysis whether everything goes as expected. And if it goes as expected, then we say this is an indication that measurement quality is good. I think it's a useful approach, but it of course has its limitations as well, because if we want to take a peek into this black box, we cannot do it without a frame of reference. We always need to take a particular position of departure, and we always need to start from a particular theory of measurement. And so if we try to model measurement processes, we need to take a certain point of departure, a vantage point, and we rely on auxiliary theories of measurements. And so they are called auxiliary theories because it's not really the theories that we want to test, but we use them indirectly, you would say, to measure. And once we have measured something adequately, then we can continue testing our substantive theories. And what is important here is that we keep this in mind. I think people forget this too often. We use particular practices, statistical models, but we forget that they rely on a particular theory of measurement. And we often forget to ask ourselves the question, is this the appropriate theory of measurement? Right? Now, I think most of these statistical models, they in some way have as a underlying logic classical test theory. Right? And so the idea here is that we observe certain things. For example, we observe a response on a survey item, but what we observe does never completely match what we want to measure. What we really want to measure is the true score, and you could say it's a bit more philosophical concept because it's very hard to get at. But it's important to realize that the true score is always contaminated. There's always sources of systematic bias creeping in, invalidity. There's sources of random errors creeping in, error here. And so I think it's useful to keep in the back of our minds that always when we observe something, there's the risk that we have invalidity and error. And so if we want to model statistically measurement processes, the whole idea is that you try to separate to the extent possible the true score from these sources of error. But here we are confronted with a huge problem. And what is the problem? If you just have, for example, a single survey measurement, a single survey item, how do you go about disentangling these sources? It's impossible to disentangle them because we don't have enough information. In a more formal way, you could say this model is not identified, right? And so how can we get a better idea of the importance of invalidity and error? If T is unknown, well, we need to change certain things in our design that give us the degrees of freedom to really investigate this. And so really an approach that is used very often is that we say, okay, why don't we use multiple indicators of one and the same true score? By doing so, we gain degrees of freedom, and it allows us to try to separate the invalidity and the error from the true score. But we can only do this if we make particular assumptions on a measurement model. And so the whole logic of testing measurements, I think, is making the assumptions of the measurement model explicit and then try to refute them, right? And so what we often forget is that we should try to work in the spirit of Karl Popper, that we can never be sure that our measurement is good, but at least if we make assumptions about the underlying measurement model, if we're able to refute them, then we know that something is wrong with the measurement. And so maybe the term that we use, measurement validation, does not really express this. I think there's as much merit in refuting a certain measurement model than in purely measurement validation. But I'm pretty confident that not everybody would agree with this. So this is probably a point for discussion, right? Okay, this is a very generic theory of measurement. When we really want to estimate measurement models, we have to be more specific, right? And there exists different theories of measurement, right? And I will just explain or briefly introduce two theories. Why these two theories? Because they occupy a prominent position in the discussion we had with Christian Welzel and colleagues, but also because they are the most often used ones, I think. So one approach is the theory of reflective measurement, or the sometimes called dimensional logic, right? And the idea here is that we have a concept that we want to measure, C. It's something that you cannot observe directly. It's a latent concept. And so what we do instead, we try to select multiple indicators that reflect this concept. And these indicators, they are interchangeable, right? So you could say that they are a sample of possible indicators from an infinite population of possible indicators. And what is important in the logic here, in this theory of measurement, is that the indicators follow from the underlying concept. They do not exist without this underlying concept. So they reflect it, right? And this is typically the logic that I have in mind when I think about, for example, measuring attitudes or values. When I want to measure attitudes towards a particular group in society, for example, what do we do in surveys? We translate, or we try to design several items that are statements about the outgroup that reflect directly or indirectly the underlying attitude towards this outgroup. And then indirectly, by means of the responses of on these indicators, we make a claim what the underlying attitude is. But it's important the underlying attitude is first, and then the indicators follow from it, right? And this is quite different from formative measurement, the combinatory logic. And here the idea is that the indicators, they exist, they are prior to the concept, and they actually cause the concept, right? And so a very good example, I think here is, if you think about a concept like household income, right? So what we want to measure is household income. And so what could we do? Well, we could ask people about difference of sources of income, right? So how much is the income that members in your household earn from labor? And how much do you get from social benefits? How much do you get from capital investments? And these all exist independently from the household income, but they contribute to the household income. So they cause the household income. And so it's a very different theory of measurement, a very different logic. And the same logic is often applied in the measurement of socioeconomic status. And what I think is important, and what we forget very often, that if we use a particular technique, that we really should think about, okay, is this technique suitable for the underlying theory of measurement that we have, right? Because the theories of measurement, they are really linked to statistical approaches. For example, the reflective measurement here, what we would assume is that the indicators, they are internally coherent, right? If they all reflect one and the same underlying attitude, they should intercorrelate strongly. So we can assess the measurement quality by looking at internal coherence. And this is typically what statistical tools that are based on factor analysis do, right? And so this is certainly not the case for formative measurement models, where the idea is that, okay, the different indicators, they should not necessarily correlate among themselves. They can be really independent. Think about the income. Empirically, the more income people have from capital investments, probably the less income they have from social benefits. So it's not necessarily internally coherent. They contribute independently to the construct, but it's a very different way of thinking about measurement, and yeah, it requires a very different approach in terms of statistical models. Right? Now, when we think about values, measuring cultural values, what is the most appropriate logic? Well, maybe I should stress that there are different logics. You could say that they are point of departures, but of course they are not without consequence, and you should not pick just any position random. No, it's a principled position that you take, and then based on that position that you take, you can perform one or the other statistical tests, right? So what is the most useful principled position when you think about cultural values? My understanding, my opinion, but also here not everybody will agree, is that the reflective logic is the most the most suitable logic. Think about Schwartz basic human values. And for example, the portrait value questionnaire that is used to measure. I assume for a moment that you're all more or less familiar with these measurements, but so the idea is that different portraits are presented to respondents, and then they say, okay, this person is very much like me or not, and based on that, we infer what their value priorities are. And we have multiple portraits to measure a particular value dimension. Here, I would say it's a good example of reflective measurement. Why? Well, the portraits, they are interchangeable, right? We could have constructed other portraits that would have been as good, right? And all these portraits, they are typically error prone, right? And if we put them together, and if they really measure the same value type, they should intercorrelate strongly. Right? But this is not the only position that you could have in value research. And so, for example, part of the discussion with Christian Welzel and colleagues is that their claim is that if you have a value dimension such as the emancipatory value index, that it's not a reflective measurement, but it's a formative measurement. And so they say we take the arithmetic mean of 12 items in 4 domains, and these 4 domains, they are not interchangeable, they are theoretically chosen. So it's a formative logic. And for the domains, to a certain extent, I buy the argument, but then within the domains, they are measured by multiple indicators each. And here I do see the logic of reflective measurement creeping in, but it would take me too long to have this discussion here. So my position is that very often the logic of reflective measurement is the one that we take. Okay, I have taken a lot of time now just to talk about the basics of measurement. And so this is not necessarily about comparability of measurement in variance testing. It's really general principles, and I hope it was not too basic of an explanation for you, and I hope it was useful. But now I would like to zoom in on comparability of measurements, right? So if you buy the argument that we're taking the approach of statistical modeling to study the measurement process, and if you buy the argument that reflective measurement is the model, the paradigm in which we work, then the concept of measurement invariance becomes really important, right? And so here the concept of measurement invariance in a very basic definition is if you have different conditions in which you observe, in which you use particular indicators, do they really yield measurements of the same attribute, of the same underlying construct, right? And so you could formalize this, and here you see that we're really working in the reflective tradition. If you measure a particular indicator X, we assume that it reflects an underlying true score T. And when is a measurement invariant across particular groups? If there is no direct effect of the grouping variable G, in this case, on X. Right? And so if X is conditionally independent from the grouping variable, this is quite formal. Let's use an example. I take an example that is maybe a bit further from the topic of the seminar, but I think it's easy to think about this issue in this particular way. Think about an intelligence test, right? So what we want to measure is intelligence. Intelligence is the T, the true score. What we do is we have a particular test, a particular question that we ask, or an exercise that somebody needs to solve. And this is the X, is what we observe. Is somebody able to solve the exercise, the question or not, right? And we want that this intelligence is measured invariantly across groups. So different groups in society, whether you belong to a particular group, the measurement operation should not be influenced by this group. It does not necessarily imply that by definition every group that we investigate needs to be as intelligent, that they need to have the same score. No, there can be a relation between T and G, but then the measurement should be independent from the group. Or in other words, if you take 2 persons from a different group that have the same score on T, that are as intelligent, they should perform equally well on your exercise. And if this is the case, then we say your measurement is invariant, it's comparable, right? and we can work with it. Right? Okay, see that I'm slower than expected, so I'll skip a couple of slides. But so what is the measurement invariance procedure and approach about? It's trying to assess this assumption of conditional independence, right? And how can we do it? Well, we can do it by means of different statistical approaches. But what is important to notice is that we can have problems with invariance. We can have what we call inequivalence for different reasons, and they have different consequences, right? So it could be the case that we have what we call is a uniform bias. And this is what you see here on the slide. This is that the grouping variable has a direct effect on X. It means even controlling for the true score, particular groups score higher on the X. So something in the X does not only tap the T, but it also taps the grouping in a uniform way. It means that there is a positive or a negative upward or downward bias, but it's uniform, right? What could also be the case, it's a bit more tricky form of bias to investigate, is that we have non-uniform bias, is that the grouping variable does not directly affect the outcome X, but that it affects the relationship between the true score and the indicator. It's saying that in certain groups, X is a strong indicator of T. In other groups, it's maybe not a very good indicator of T, right? And so it's these kind of assumptions that we try to test by means of invariance testing, right? I'll skip a couple of slides here as well. And so the whole logic of invariance testing is that there are all kinds of biases that can creep in. And if we want to make proper comparisons across individuals or across groups, countries, then we need to be sure that these biases are not present, because they could really distort the picture. And so how do we do it? Well, we try to transpose this idea of conditional independence into testable hypotheses. And concretely, what we say, let's take multiple indicators, right? And let's estimate a measurement model in every group with an underlying latent variable. If these measurement models are similar across the groups, it's an indication that this conditional independence assumption is fulfilled. If it's not the case, then it's an indication that the conditional independence assumption is not fulfilled and bias might creep in. And how you do this? Well, here there exists many different ways of testing these assumptions. So very often multi-group confirmatory factor analysis is used, but there exist other approaches as well, IRT models, latent class or latent profile models, if you assume that your latent variable is categorical rather than continuous. So it's not just one approach, but it's a whole list of statistical approaches that you can use, and they all go at the same thing. They try to assess this assumption of conditional independence. So, for example, in the multi-group confirmatory factor analysis approach, what you would typically do is formulate measurement models, factor models in different groups, and then try to see if certain measurement parameters, such as item intercepts or such as factor loadings, whether they are similar across the groups or not. And if they are similar, it's an indication that measurements are comparable. Okay, now this is the whole underlying logic. But throughout the discussion with Christian Welzel and colleagues, I think something that came more to my mind, or that I think that we need to emphasize more, is that these statistical tests, that they are not a direct test of measurement quality. So they are not identical to measurement quality. It's neither a necessary nor a sufficient condition for measurement quality. And why do I say this? Well, what we do here, we assume a very specific theory of measurement, reflective model, and then we deduce hypotheses from it and we test these, right? But of course, if the point of departure is wrong, then it's a problem. And it also only looks at one aspect of measurement quality, comparability, right? And then if you look at the practice of these tests, then we see that there's often a bit of a problem. And what is the problem? That we have very powerful statistical tests, and that often we detect really tiny differences in the measurement models between groups. and that if you're too strict, you tend to conclude easily that you cannot make comparisons at all, while this is not necessarily true. Maybe there is a difference in the measurement model, but it's not really relevant. So this is also a tricky point. So I'm certainly aware that we should not mindlessly apply these techniques and blindly adhering statistical criteria, and that we should not use them without thinking about the underlying measurement model, measurement theory. Okay, good. I have one more point. If I can take a couple of more minutes, Meuleman, if that is okay for you? Yeah, all right, good. Now, you can already see here that I still see use in measurement invariance testing, but I do think that we should not use it blindly. One important aspect that, for my opinion on this, is that, I mean, I don't see really good alternatives that could replace this approach. I mean, it's not the only way of looking at measurements, but other ways they contend with their own problems as well. And so what Welzel and colleagues specifically propose is that we should do more external validation. So we measure something, we aggregate it at the cultural level, and then we see if measurements correlate as expected in nomological networks. And then if this is as expected, then it's an argument for the quality of the measurements. And here I take issue with this logic a little bit, or I see a problem. And why? Because we have a gap between, on one hand, the individual level, and on the other hand, the cultural level. And this is a big gap. It's not so easy to bridge. Now, our measurements, they happen at the individual level. We ask individuals questions, but then very often we try to make statements about the cultural level, right? And so one critique that you could have on multi-group confirmatory factor analysis and similar techniques is that they only focus on within group covariances. They look at correlational structures within cultures. So how can you say something about comparisons between cultures if you only look within cultures, right? And so I think on the one hand, this is true, but I also think that, well, we cannot just ignore the individual, right? Because if you think what are comparative researchers interested in, I don't think they are very often interested in purely the individual level. But I do think that very often we are interested in how individuals behave and think within particular group contexts, within cultural or national contexts. So I don't think we can ignore the individual level completely. Right? You could argue that the cultural comparative research is only about groups, but I don't think this is really the case. If you look at a lot of the research that is going on, the individual level, the individual has a place there as well. And even if you're only interested in the cultural level, I think we have to acknowledge that we measure through the individual. So we cannot ignore the individual completely, I would argue. So even if you just want to make statements on populations, we have to realize that there exists a micro link underlying macro level processes, similar idea to Coleman's bathtub. And so if we want to make cultural statements, we always have to take care about the individual level. So if the measurement at the individual level is not happening properly, and then your aggregation is problematic as well. And here, what I want to stress is that if you take a look at the practice of measurement invariance testing, such as factor analytical approaches, there is a lot of research going on that shows how extensions of these models, for example, multi-level CFA, can explicitly address this aggregation, right? And so this is the whole issue of measurement isomorphism, and the question, can we aggregate a concept measured at the individual level to the higher level? Do concepts travel across levels? And here we need to acknowledge that there can be a difference in measurement from one level to the next. So we should really investigate it. It contains useful information. Maybe a last point before I come to the conclusion. If you think about factor analytic approaches and something like multi-level SEM, I think it's not a good idea to throw it out completely. I would say it offers very good opportunities exactly to investigate why in certain cases our measurement goes off the rails, right? And for example, you could explicitly model why particular indicators behave different in some countries than in the other. And here, I don't have the time to explain in detail, but here you see a multi-level circular equation model where you see that the value type universalism of the Schwarz value scale is measured. And then you see that environment, the item on environment apparently functions differently in countries in the European Social Survey. And we can explain it partially by taking the Human Development Index into account. Okay, so this illustrates that even if you fail to confirm the hypothesis of measurement invariance, it's not necessarily a bad thing. We can learn a lot about differences in cultures if we understand why items function differently from one group to the next. Okay, let me come to a conclusion. So the question that we started from is, what is our practice of measurement invariance testing? Is it still useful? Do we need a paradigm shift? Do we, for example, need to replace measurement invariance testing by more external validation, such as looking into nomological networks? And I would say, no, I think it's still a very relevant and useful technique. One reason is that the alternatives are problematic in their own respect, right? So if you think about external validation at the aggregate level, there also you assume all kinds of measurement theories, but you don't make any attempts to really test them, right? So there is no attention to how scores are mapped. And in fact, you could say it makes the measurement theories less transparent. We are less inclined to talk about it, right? Also, if you use external validation at the aggregate level, you use a very specific conception of comparative research. It's the idea that only group matters, only the cultural level matters, and you really ignore what happens at the individual level. And then statistically, and I think here the commentary of Ronald Fisher and colleagues is very relevant to read. You cannot put too much weight on external validity because there is all kinds of nomological noise that can be present. All kind of other method factors can creep in. And if you use that logic, then you're bound to conclude that everything that correlates with something else, it's a good measure. So you could say that it makes falsification more difficult. It becomes virtually impossible. And I'm afraid if you put too much emphasis on this, then you end up in a situation that anything goes, that you can't really distinguish between comparable measures and incomparable measures. So I think measurement invariance still has its place, but we need constant developments, like, for example, the multi-level CFA models where we can test aggregation. And I also think that we should avoid mechanical application. And here I really buy the critique of Welser and colleagues. We should not equate the fit of a multi-group CFA model with comparability. No, it's really a very specific test that starts from a specific measurement theory. It's not useful in all cases, and we should really be sure that we do not make too much fuss about tiny differences. I do think if we use these models, I think they are relevant, but we should never forget that they work from a particular theory of measurement. And I also think that we should not make too much fuss about differences that are too small. And rather than throwing the whole methodology out, I think we should invest more in fine-tuning it and developing it further. And this is certainly going on right now. All right, I'll stop here. My apologies for taking more time than anticipated. I look forward to the discussion.